Well, hello viewers. In this video, we will look at a sample project slash application appropriately named the solar tracker that we will build with Edison Robot and Lego blocks. So the agenda for this video is first we will look at the project overview, what this project is about. Then we will look at the prerequisites which are required by the viewers before they can benefit from this video slash project and able to implement um, this project on their own. Then we'll look at the working demo project. Then we'll look at the Lego pieces, the physical structure, how the physical side of this project was done. Then in the end, we'll look at the code review, what code is running on the two Edison robots which are required to build this project. So for the overview in this project, we'll see two Edison robots basically building a solar tracker, and they will orient a simulated solar panel in the direction of the light, which will maximize the amount of light falling on the surface of the solar panel, hence it will increase the power output of the solar panel. This is medium to high difficulty level. It's especially high if this task is given to the students and they need to come up with the structure and design of the physical side of the solar panel tracker themselves, because it requires considerable understanding of how to make the structure stable and make it work um, using the two Edison robots. Or you can follow along with the video and it will give you some idea to build it yourself. So what are the prerequisites for this video before the viewers can benefit from the content? The viewer should have the understanding of how Edison robots work. They should be able to program the Edison robot, and especially the light tracking robots, how the light sensors are working, and different driving modes or driving mechanisms used by the robot to drive left, right, forward, backward, and spin around. So I should have some good idea of how those wheels for the robots operate for those different driving mechanisms. It's also beneficial the users have done some scripting in Python, because the two programs that are loaded in the robots are in Python. Then on the physical side, it's also good and really beneficial for the viewers if they have understanding of basically gears, leverage, and other basic mechanical and structural mechanism that will help them understand how the physical or structural side of the project with the two Edison robots and Lego is working together to make this solar tractor possible.
Okay, so this is the solar tracker that you see in front of you. This is the simulated solar panel, which is supposed to face the light all the time. Now, in order to achieve that, there are two Edison robots, the one at the top and the one at the bottom. The top one is responsible for moving the solar panel up or down, like facing upward or facing a little bit towards the side, towards the horizon. And the one at the bottom is responsible for moving the whole structure left or right, so the solar panel is always facing the light. As you can see, this is not a trivial project to be undertaken. So if your students want to develop this, they may have to do this in a few settings with the help from the teacher, who already knows or has an idea of how the structure is going to go together, as I will break down this structure and components in this video further to show you what was the thought process, what are the different challenges I faced, and this is all based on my thinking, and it is not copied over from any existing design. The strings that you see over here, they basically wind up and help this whole structure move. So if the structure is going to move towards one direction, that is still the string will start winding up and the structure will start moving in that direction. If the structure needs to go up, this string will start winding up and the structure will start going up. So there are two separate programs running in each of these Edison robots. So now let's do a quick demo. And in order to do the demo, I'll have to turn off the lights. So you can see how the Edison robots move the solar panel in the direction of the light. Okay, so I've turned on the Edison robots and I've also switched off the lights. So now we are going to see the demonstration of how the two Edison robots here are able to keep this solar panel pointed towards the direction of the light. And obviously we are using the light sensors on the left and right in each one of those to orient the simulated solar panel in the correct direction. So this is going to be my source of light. So let me turn on the Edison robots, and for that I require something like a sharp stick because it's very little space to put my fingers through. So the bottom one Edison robot is ready to go, and since there is no much light, they are not turning right now, and now the top one is also ready to go. So both the Edison robots are ready. So let me show you the demo. So right now I'm activating the top Edison robots. It's comparing the light level between the left and the right light sensors, and you can see it's slowly moving up and it will reach an optimal level and then it will stop moving. Okay, now it has reached, you can see a of the solar panel is almost pointing upwards instead of pointing more towards the horizon, towards the side. Now if I move the light level down a little bit, it's going to move back the so now it's coming back and orienting itself again in the direction of the light. And once it had the optimal direction, it will stop going further down. Okay, so yes, yeah. Now let's look at the bottom robot. Let's look at the bottom robot. Okay. Here is the bottom robot, which is moving the whole structure. And here's the top robot again, which is orienting the solar panel in the upward direction. Now obviously the top robot takes a lot of time because of the set of gears, and it's doing a heavy lifting of lifting this whole Edison robot up, while the bottom one is just turning it left or right. So if I come toward the bottom one, it's going to just orient, and that's it. Now one more thing I'm going to show you is from the side, how does all the gears are working. So this is my source of light over here, and you will see that if I bring this light source up, the gears start turning, and this is the string which is winding up, and this string is causing the Edison robot to start facing up. Okay, it's pulling down on this part, and this is the um, pivot point where the whole structure is rotating. Okay, if I bring the same light down, these gears are turning back, and solar panel is going to face the direction of the light again. Okay, so just a little bit more light on the gear so you can see it clearly. So this is the downward motion, and this is the upward motion. And this is the downward motion once more time. Okay, now for the bottom robot, okay, I'm going to show you the bottom robot now. One of the strings kind of came off, so I had to reattach it. So we'll see that the bottom robot is moving right now. Okay, and this is the top one. Now if I go on this direction, you will see both of them sort of will move, and the bottom one is stopped and the top one is stopped. Now I'm going to show you the mechanism how the Edison robots have been set up in this configuration to allow this solar panel to always point in the direction of the light. So there are two parts to it. The bottom robot is the one which is responsible for the left or right orientation of the solar panel, and the top one is responsible for up and down orientation of the solar panel. Okay, so we can actually study this in two separate parts. So this is the top one that I am taking off from here, and you can see that this one has a string which is attached to this yellow piece on the bottom robot. So when this string winds up, this pulls the whole structure down and it moves the solar panel towards in the upward direction towards the sky. When this string is unwound, it becomes loose, So when it's tight, it goes up, and when it becomes loose, it faces the forward direction. The gravity, the weight, and the of the Edison robots, and the center of gravity somewhere here, brings the keeps the structure more facing towards the side. So we need sort of one string over here to just pull the structure up, and then loosen that same string to pull it down. Now obviously, this Edison robot, the left and right light levels are, if you're putting it horizontal, but if you're putting it vertical, it's gonna go up and down to based on where the light is. Now obviously, the motion of the wheels for the Edison robot is over here. You see where that gear is. This gear actually turns this structure over here, and this structure is just simply resting on the Edison robot. Okay, so when this Edison robot, I'll put it on the side, turns this structure around, it winds up this string. So it was necessary to convert this direction of motion of the structure in through gears into so instead of tying it horizontally, it will tie the string vertically. So you can see there is, it's better if you have a worm gear. I didn't have a worm gear, so I just converted the vertical orientation of the gears into more like a horizontal orientation of the gears, and this string correspondingly winds up, brings the whole structure down. Since this structure is, this is the point of support for this whole structure, when it brings it down, it lifts up the solar panel. Initially I had the Edison robot above this structure, and it would keep falling down, so that was not a good design. So I had to support it in such a way that the center of gravity is always lower than this point, so that it won't topple over. It would keep falling over onto the back or to the front side. It was very unstable. So keep your center of gravity lower, and you can see the construction of this this gear piece, which is transforming the vertical into horizontal gear motion, and is also doing some gear torque increase and speed reduction here, so that you have a high you can apply higher force. From Edison cannot provide that much force, so you have to come up with a setup to increase your torque on this piece which is winding up your string, because you have to lift up the whole structure. That's the reason why this portion is slow, because it results in raising up the whole structure. So that's for the top piece. Now I'm going to discuss the bottom piece. Similar to the one, it has the one difference is, if you look at on the top one, is that I'm just using one the left side of the wheel, so it's just left motor. So I'll show you the program. It's just using the left motor. This Edison is actually similar to the light chasing program, and instead of the light chasing, it's just spinning left and right. And initially I just had it on the wheels on the ground, but Edison didn't have enough power, and it was too much friction, that if you just use Edison with these wheels, and which is a simpler setup, and try to just turn it left or right with this much weight, it just keeps turning off and it won't move. So what I had initially, that was the one what I did initially. So this time I changed the setup. So what I have here is I'll show you at the bottom that it can swivel on a piece that I had for Lego. These two strings, if it going on the left direction, the way this wheel turn winds up this string, and it turns in the left direction. if it is going towards the right, like we're looking from the right direction, then this string winds up, and then the other one unwinds. So one of them winds, the other one unwinds, and it results in your bottom Edison basically changing its orientation, and correspondingly the whole structure on top of it also faces the direction of the light. Now what I have at the bottom is, if I take it off, kind of stuck pretty good there. Okay, so it's resting on these two pieces, and this is my swivel point. So this is the piece that I use to for swivel. It's really jammed. Yeah, this is what I'm using for swiveling. It connects to the bottom over here, and you connect it over here, and you attach your Edison Robot on top of it. The reason for using these two is that it's not enough indentation here. It's not enough room here for this gray piece to directly attach to here, so you have to use some extra pieces to cause those pieces to fit together. Okay, so once you have it, press the whole structure on top of it. So now you have both the structure, and then this structure goes on top of over here. Okay, so the shaft over here is the one through which Edison is connected to this gear structure, and that's it. There's no other connection. The shaft is also responsible for moving the structure up. This little yellow piece that basically came off, it just goes over here, and what it does, it prevents Edison from turning, because Edison is going to move the shaft, otherwise this structure could move left and right. So these two Lego blocks just prevent the structure to move in relation to the top Edison robot. If you look at it closely inside, you can see the gear mechanism, how this gear over here turns this one, and there's a gear reduction going on from this one. You get the power into this one, and then this is where the string is being wound up, and that's just a structure of how to enable a heavy load through Edison to be able to lift the Edison robot up. But we have to not just lift a load, we have to actually lift the whole Edison up, and the reason for that is the light levels can change based on whether the Edison is facing the light or not. So that's the whole purpose. That's the reason why this Edison and as well as this one needs to move in relation to the light, so the light detection sensors can detect which direction the light is and can move the Edison up or down, or left and right. Okay, so what are some of the pieces required for this? So there are special pieces. One of the things I'm using for this is I bought it on Amazon a while back, and it has a lot of these sorted gears and special Lego pieces with holes in it. These are the same holes that you see over here that are on which the gears are riding, and as well as the gears are also from the same piece. This one also is from the same set. These, if I remove this one, these ones that have holes in them are also from the same set, and the rest of them I am using the regular pieces just to put the structure together. I had another set from which I'm using these pieces. You can probably use something else to basically raise the level of your Edison so that it can swing freely between these 2 points. But you do need these kind of pieces that have holes in it so that the gear shafts can go through, and you can use it for either swiveling, or you can use it for turning your gears and transferring power to your shafts. The same set also gave me these two that you see over here. These two pieces that I'm using to turn the bottom robot. Yeah, and that's about it. Those are some of those pieces that look like this, the holes in it, and these are the regular pieces that I use for just for putting this structure together. One thing is that there's not enough room in Edison to just attach a piece in a perpendicular direction, so you have to attach these little pieces to give enough to raise that holes enough so that you can actually attach a piece perpendicular like what you have over here, these two pieces, right? The one on the top over here, they don't require additional pieces. Okay, and that's the setup.
Well, we are now going to discuss the program that runs on the two solar tracker. So there are two programs, one for the top one and one for the bottom one. What this one is doing is essentially is a big while loop in which it keeps monitoring the light. So these two statements, either the first one will execute or second one will execute, or they both will not execute because the condition for them are different. So the first one checks the left light level, and if it is greater than the right light level by 50 points, like you don't want to immediately just look at, oh yeah, the left light level is greater, so start moving left, or the right light level is greater than start moving. Because a lot of times in these control systems, there are a lot of like noise, false readings, which are bouncing around the threshold. One of the sensor is reading a little bit more than the other one, so you start. So you give it a 50-point buffer. What this does is that unless the light has really moved to the left by 50 points, that is this threshold, the level here, the luminescence brightness on the left side is greater than the right side plus 50, that is the light has really moved to the left, it will not enter this. And then similarly, if the right hasn't, if it hasn't yet moved to the right by 50 basis point compared to the left, it will not enter this if condition. So now if the light truly does move by 50 or 50 luminescence sensor level 50 basis point more than the left, then it will enter this condition. It will start driving. This 2 is actually representing backward. I'm using just the left motor because for the top robot, if you remember, there's only one shaft connected to one of the wheel, and that's the left wheel. So the left motor is we're moving backward, and that helps to bring um, the solar panel as well as your top Edison robot upwards from the side. And while it's doing that, so it will keep at the speed of 5, and it will keep doing it because PD distance unlimited executes like a thread in the background. And in order to keep executing it, we have this while loop. So you enter this if condition, you see that the light has really moved towards the left by more than 50 points just compared to the right level, then you keep executing this one. But the condition here is different. The condition is not taking this 50 into account because at this point we have determined that the light is really to the left, and we have to keep moving it until the left and the right sensors levels almost aligned. So while the left light level is still little greater than the right light level, it will keep doing it until the right light level reaches the left or is maybe overshoots a little bit. So it will keep moving your iron. So your Edison Robot, if I give a visual for it, suppose this is the light source and we are looking from the top, and this is the left sensor, this is the right sensor. If you move a little bit to the left and it hasn't crossed the 50 threshold mark, that is the difference between this and the left sensor and the right sensor is not more than 50, then it will not do anything. But once it reaches 50, it will start, this whole thing will start turning left, and and then it will turn left until until it's basically until it basically equalizes the left and the right um, sensor levels. So that's the idea. So it's kind of moves in episodes. So it's wait for the light to reach a certain level and then it completely turns in that direction. Otherwise, if you do not have this 50 in here, what will happen is that your Edison will always be like, because of the noise in the sensors, will be somewhere jerking in that mid range. Sometimes it left side will um, read more left sensor, sometimes the right sensor will read more. So it will jerk between these two. You don't want this to, you want for it to wait till the light reaches certain left levels or right level, and you want it to turn in one go and cover some decent amount, some acceptable decent amount. And this is the same concept which is applied on the um, thermostats which are working on your air conditioner or home heating, that it reaches a certain level, like if you set it at 4 degrees Celsius, it will let it go down, go up to maybe 4.3, and then all of a sudden the compressor will kick in and bring your temperature down to 3.5 or 3.8, and then it will let it slowly rise. Otherwise, the compressor will be turning on and on very quickly, depending on the little variations in the temperatures. You don't want that to happen. You want a certain threshold established and a safe area during which the light can basically move around. And in this area, for example, in this area, neither of the sensor will kick, and neither of those code blocks will kick in because the light has not crossed the threshold which warrants an action by the Edison robot. So in our case, the top robot, if the light is towards the left, this is the top side because it's in a oriented in a vertical direction. It will, the solar panel will point towards the sky. If the light goes down, the string will start unwinding, and because of the gravity, the solar panel will start facing more towards the side and not towards the top. Similarly, I changed the bottom tracker. See, the bottom tracker is doing the same thing. So again, it's the same 50 threshold. We have the left light level, which is greater than the right light level by 50, and then it enters this loop. If that is the case, and in this condition, if that is the case, then it will drive left, and then this is the so I'm not using the unlimited driving condition because going too fast and causing a lot of problems in the strings. So I'm doing it in jerks with small steps. So it tries to move by about like say 10 centimeter uh, swing left, which in our case we are just winding the string. So it moves towards the left, and as long as the left light level again is greater than the right light level, it will keep doing it until. So we have already over here as before determined that the light has really moved towards the left and it is exceeding by right sensor by 50 points. So we have to turn it in the left direction and until finally the right light level or the right sensor start measuring about the same or maybe overshoots and measures a little more than the left light level. And then we will stop over here. Um, like similar to this one once this the difference is that on the top one this is unlimited, so to keep this while you're in the while loop, this statement keeps executing, and then when it finally reaches that threshold or that uh, level where the two sensors are reading the same, it stops. Similarly, at the bottom, uh, Edison Robot. Over here, since we are not doing unlimited, so we have to keep driving um, spinning to the left. And then when the sensor on the left light level reaches the right light level, then we stop over here. Similarly, on the right side, if we have a left right level, which is 50 less than the right, means the right light level is greater than left right level, that is the right sensor is measuring 50 more than the right, means the light has really moved to the right. We spin right, and then in this while loop until the um, right light level is greater than the left light level, that is, we're still measuring the right sensor, is still measuring light greater than the left sensor. We keep spinning right until it overshoots and the right sensor measures a little more or about the same, then it stops. Correct. So this is to prevent this 50 over here that you see over here, and this program is to prevent again your Edison robot to misread or bounce between those very close ranges. So you want a certain threshold before it moves and then covers that distance. Then again move and covers that distance. All right. So that will be the end of the program. Thank you.